In this chapter, we talk about estimation. Through this chapter, we just find an interval for all the examples. Okay, we just need to find an interval, and for finding an interval at each topic, we have a specific rule for finding it. In this chapter, we have 6 topics: confidence interval for one mean, confidence interval for the difference of two means. When we say two means you have two different populations, two means, and those, okay? This is two. The confidence interval of population proportion, if we have only one population, and the confidence interval for the difference of two proportions. In this case, we have two populations. And then the confidence interval for a variance. If we have only one population, we are asked to find the confidence interval for its variance. We need to find an interval for the variance. And then finally, we have the confidence interval of the ratio of two variances. A ratio of two variances. We have these 6 topics in this chapter. Okay. First, these are, it's just for yourselves. You could read these. We now have confidence interval for the mean. Here, we have confidence interval for the mean. Before we talk about it, first let me tell you something about how to find the percentage of the confidence interval, or alpha. Okay? We say, if we are asked to find, let's say, 90%, 90% confidence interval for the mean. In the example, it's given that find the confidence interval for the mean, for the variance, for the difference of variances, for the difference of proportions. It's given in the example. Okay? From the example, you directly know what case is. Okay? To find this, we need alpha. What's alpha? Alpha is 1 minus this percentage. This percent is 90%, means it's 0.90. Is it? It's 0.9. It's 0.9. 1 minus 0.9 is 0.1. This is alpha. It's important to find alpha first. Okay? What if we are asked to find the 90% of 95% of confidence interval for the mean? It's the same in all of the cases. Okay? In all of the topics. Here, alpha is 1 minus. This is 95. 95% means 0.95. And the result is 0.05. It's important to find this. Okay? Because we need a set of this value, alpha over 2, in most of them. We need to find this. And the table for Z is given. You just pick it from the table. For the confidence interval of the mean, we have 3 cases. For the first topic, we have 3 cases. If the population variance is given, if the population variance is known, here we either have the variance or the standard deviation. Even if we have the standard deviation, by squaring it, we get the variance. Okay? What if the variance is unknown? In that case, we have another 2 cases. Okay? If we have unknown variance, in the first one, we say if the sample size is greater than or equal to 30. And in the second, if the sample is less than 30. We have these three cases for confidence interval of the mean. We have three cases. If the variance is given, and if the variance is not given, we look at the population size. If it is greater than 30 or less than 30. Okay? Greater than or equal to 30, it's a case. If the population size is less than 30, is another case. We now talk about the rules for each of these cases. That's it. For case A, the confidence interval for population mean U with known population variance. If the population variance is given, it's the first case. The rule is this one. We say mu is between this and that. What are these two? This is L, this is U. I name that. This is lower, this is upper. What are these? This is the interval of L and U. L is the lower point of the interval, and it's about the everyone. As you said, we need to find this interval. For any interval, let's say it's 2, 3. This represents L and this represents U. Okay, here we find these two, L and U. L could be obtained from this rule, and U is this. Look, there is a similarity between L and U in all rules. Here, if this one is negative, so this one is positive. Look, the difference between these two rules is only these two signs. Here it is negative, and here is positive. That's all. Okay? So now, we use this rule for finding the interval. For the percentage of confidence interval of the mean, if the variance is given. If the variance is given. Okay? Variance means sigma squared. Sigma squared is variance. But here we have sigma, means we need to take the square root of variance. Or sigma is S, and sigma squared is S squared. S is standard deviation. It is standard deviation. If the standard deviation is given or variance is given, in both, we could get variance. Okay? In both cases, we need to use this rule for finding the confidence interval of the mean. What if it's the same? Okay, this is written here and this is written here. It's the interval. You need to write down as an interval. Then, what if the population variance, or if the variance is unknown? If the variance is unknown, but the number of sample size is greater than or equal to 30. Here we have n is greater than or equal to 30. If the number of sample size is greater than or equal to 30, we use this rule. We use this rule. This is lower and this is upper. You need to memorize these rules. You need to know these rules. This is L and this is U. You need to write down the final result as an interval. L and U. You see, this is the confidence interval, the required confidence interval. The third case, in the third case, you see if n is less than 30 and the variance is unknown. We have three cases here in this topic. If the variance is given, it is the first case. If the variance is unknown, then we look at n. If it is greater than or equal to 30, it's this rule. And if it is less than 30, is this rule. Look, here we have Z of alpha over 2. Z of alpha over 2. But in the case if n is less than 30 and variance is unknown, we use T of alpha over 2 and n minus 1. T of alpha over 2 and n minus 1. Okay? That's it. From the tables, we could get these. Tables for T, for Z, for F, for chi-squared, for all those should be given during exams. Okay? So if we know the rules, it's easy to calculate this. It's just calculation here. N is given, X bar is given, S is given. And also T could be obtained from the table. So you could get it. Okay? This is for the population, for the mean confidence interval for the mean. As we have 3 cases. Look, we have an example here. It says compressive strength of concrete is normally distributed with standard deviation. Look, standard deviation is given. Standard deviation is given. This amount of Pascal. A sample of 16 and is 16. Write down all the given information. Here, sigma is given and n is given. Has been randomly selected, which give us the sample mean, this X bar. X bar is given also. It says, construct 95% confidence interval for the mean. Look, it says for the mean. Means it's the first case, and not the first case, the first topic. It's the first topic. In that topic, we have 3 cases. Which case is, as the variance is given, it's the first case. Okay? As the variance is given, is the first case. The first topic is confidence interval for the mean. Here we have 3 cases. A, if the population variance is given, standard deviation is given, means you could get variance by squaring the standard deviation. In the second case, if the standard deviation is unknown and n is greater than or equal to 30. In the third case, we have if the standard deviation is unknown or the variance is unknown and n is less than 30. We have these 3 cases in this topic. As in the example, it says for the mean confidence interval on the mean compressive strength. That means it's the first topic, confidence interval of the mean. In that topic, we have 3 cases. If the variance is given, if it's not given, it's the other 2 cases. Now, the standard deviation is given. From the standard deviation, we could get the variance. So the variance is given. As the variance is given, so it's the first case. It is the first case. And now, n is given, which is 16. Sigma is given. X bar is given. And also, we have given 95% confidence interval. From this one, what we find? Alpha. Alpha is 1 minus 0.95, which is 0.05. This is alpha. Now, we have a table for finding Z of alpha over 2. As in the rule, look at the first one. In the rule, we have Z of alpha over 2. This is Z of alpha over 2. This one is. And it also have Z of alpha over 2 here. We have a table for calculating Z of alpha over 2. Okay? Let's return to the table. This table, we have Z table, Z critical value for the confidence level. Okay, it's used for only the confidence level. Alpha is what? 0.05. Okay, 0.05. So alpha over 2. Alpha over 2 is 0.025. We now need to find Z of 0.025. In the table, it's given that if alpha to be 0.05, the value of Z of alpha over 2 is 1.96. This is Z of alpha over 2. I don't look for Z of 0.025. Okay? Because it's this one. If alpha to be 0.05, then Z of alpha over 2 is 1.96. Means Z of alpha over 2, which is Z of 0.025, is 1.96, is it? Yes. That's it. You now have Z, X bar, N, and sigma. Let's rotate the rule. If you could get everything, that's it. We just calculate. Now, what we have? In the example, we have given X bar, we have given N, we have given sigma, and we found this one from the table. Just plug it here. In both sides, the difference between both sides is only this sign. Here is negative, in the left is negative, and in the right is positive. That's it. Just replace X bar by its value, N by its value, Z by its value, and sigma by its value. Then calculate by using calculator. That's all. So if you know the rule, it's easy to calculate. It's easy to solve the question. You should know these rules. That's it. This is X bar. This is Z times. This is sigma. And this is N. It's in the left. In the right, we have the same. But instead of this negative sign, we have plus. We have the same. Just calculate these two using calculator. You will have calculators during exams, and you'll get this interval. You'll get this interval. So mu is between this and that. Or you can write down as 2.4891 times, oh, let's see, 2.5105 times 10 to the power 7. This is our interval. So you could find a confidence interval for the mean for those given things. That's all. The important thing here is to recognize it and then write down the rule. If you know the rule and recognize, it's easy to recognize the topic actually. Here it says confidence interval on the mean. You know, you have only one population and you find the confidence interval for them. In that topic, we have 3 cases. If the variance is given and if the variance is not given. If it's a noun or it's a noun. If the variance is a noun, it's given in the example that the variance is a noun. The variance, and look, here we have an example, I think. Let me show you somewhere. Look at it. It's given. if we don't know the population variance. Even we have the variance, as we have the standard deviation, because we need to use it in the rule, in the calculations. But in the example, it should be mentioned that if the variance is unknown, it says if we don't know the population variance. Okay, so it's a case that we have no we don't know the population variance. Okay, then we look at the number of populations, if it's greater than 30 or less than 30. Even here, in one mean, it's the same. It was for two means. For one mean, it's the same. We now have second topic, which is confidence interval for the difference of two means. Difference of two means. It's similar to the previous one. Here we have three cases. In the first case, as you have two populations, means we have two variances, two mean and two sample sizes, okay? But we need to find one confidence interval. We need to find one confidence interval for the difference of them, for the difference of them. Look at this. Here, we have three cases also. We have three cases. If the variance is unknown, with known population variance. The first case is if we know the population variance, means mu1 minus mu2. In the previous one, we said only mu because we have only one population. But if we have two populations, means we have two mu's. And we need to find the confidence interval for the difference of their means. Now, we say mu1 minus mu2 is in that range that you will find. In the previous example, we say the mean is in this range. The mean is in this range. Okay? The mean is in this range. But now, for this one, we say the difference of their mean, is in that range. This is L. Look, L depends on x1 bar, x2 bar, means their mean, their variances, and their population size. It just depends on these three, and also z of alpha over 2. This is not epsilon. This is alpha. Okay? Z of alpha over 2. We could get alpha from the example, given information in the example. Now, we just need to have x1 bar, x2 bar. These two must be given in the example. Sigma 1 and sigma 2 must be given also. N1 and N2 must be given. What's not given? Only Z. But alpha is given. We could get Z from the table based on alpha. That's for the left-hand side. The right-hand side, this is L, lower. The right-hand side, just change this negative to positive. Just change that negative to positive. This is still x1 bar minus x2 bar in both sides. So we just change that negative sign to positive. This is L. We get the upper. In all of these rules, if we just know one of the sides, the other side is similar. The difference between left and right hand size is only a negative sign. Okay? This negative sign becomes positive. That's it. It's the rule for the confidence interval of the difference of two population means if the variance is given. What if the variance is unknown? What if the variance is unknown? If it's unknown, we have two cases. If it's unknown, n is greater than or equal to 30, or n is less than 30. similar to the previous one. If n1 and n2 is greater than 30, we look at their variances. We look at their variances, if their variances are equal or not. If their variances are equal or not. If the variances are equal, we use this rule. This is L and this is U. These epsilons means alpha. These are alpha, okay? Here in the exams, ASP is given. ASP is given in the list of formula, but the above rule is not. This rule is not, but ASP is given. It is x1 bar minus x2 bar, x2 bar minus z alpha over 2 ASP. ASP, we just need to calculate this one, multiplying by that square root. Look at the first hand side, left hand side. It depends on x bar. It depends on only x bar in, their means, their population size, and also ASP. ASP depends on n and S1 and S2. Look, in this type of example, we even have the standard deviation of variance, but in the example, it's given that if we don't know the population variance, or it says if the variance is unknown, it must be given that statement, and then we use this rule. Okay? If both have the same variance, if both populations have the same variance, we use this rule. But SP is given. If their variances are not equal, we have another rule. That's it. We have this rule. The rules are similar to each other, actually. Here, the difference between if the variances are given or not is only here, inside the square root. We have s squared in the case if the variances are not equal. We just have these s squares here. When you memorize these rules, you could make a relation between the rules to not memorize all the rules. You could write down one based on the other one. For example, this one based on the previous one. If you know the previous one, just inside the square root, add s squared in the numerators, you get this. Okay? Now, for the difference of two means, mu1 minus mu2, we have three cases. Generally, you have three cases. If sigma squared is known, it was the first case. Here we have three subcases. Okay. If it's okay, we have only one case there. If sigma squared is known, then what if sigma squared is unknown? But n1 and 2 is greater than or equal to 30. And here we have two subcases. We have two subcases. Case 1, if sigma 1 squared is equal to sigma 2 squared. Case 2, if sigma 1 squared doesn't equal to sigma 2 squared. Okay? The third case, we say if sigma squared is unknown and n1 and 2 is less than 30 if the sample size are less than 30. In the examples, both must be greater or equal to 30 or both must be less than 30. You'll not be given an example that one of them is greater than 30 and the other one is less than 30. Both have the same property. Both is greater or less than 30. Okay? Here we have two subcases. I, if sigma 1 squared is equal to sigma 2 squared, and double I, if sigma 1 squared doesn't equal to sigma 2 squared. So in this topic, we have 1, 2, 3, 4, 5 rules. We have 5 rules in the confidence interval for the difference of two means. Okay, we have 5 rules. We said if the variance is noun, we use this rule. If the variance is unknown, we look at the population size. If both are greater than 30, we have two cases. We look at the variances. If the variances are equal, we use this rule. But if the variances are not equal, we use this rule. This is also alpha. Okay. In the third case, if the population sizes are less than 30, if their population sizes are less than 30, we still have two subcases, if the variances are equal or not. If the variances are equal, we use this rule. But here we have T distribution. In the previous one, we had Z. We now have T of here epsilon. These epsilons means alpha, okay? This is alpha. This is alpha. Vale? Vale, تبليتي بكاري. أدريت vale, أمان. And SP always given in exams. You don't need to memorize SP. Just the rule. Okay? Look, this depends on only N, X bar, and T. The rule depends on this, and also SP. And SP depends on variances N. Okay? The population size and variances. But in the exam, look, even here, we need to use variance. Means in the example, variances are given. But there is a statement which says that if the variances are unknown, we have that statement. That's why we use this rule. Okay? If you don't see that statement, always use the first case. Means variance is known. That's it. It's also alpha. And here, this is 1 to the power 2. This is V. V is the degree of freedom. Is the degree of freedom. For what? In the T table, we need it. Is the degree of freedom. For example, V here is, let's say, 10. This degree of freedom. We need to find T of alpha over 2 and 10. Let's say alpha over 2 to be 0.05. Okay? If this is 0.05, we need to find T of 0.05 and 10. Let's go onto the table. Where is T? This is F distribution, F, and F. Let me check, it's F. This is T. Look, we need to have alpha and V. The rule of V is given in exam. Okay? This rule and SP is given. This is degree of freedom in the T table. Now, we have T of 0.05 and 10. Let's look for 0.05. That's it. And 10. This is V. We look at V in the first column. That's it. Now, it equals to 1.812. That's how to use T table. Okay? That's how to use. The V is degree of freedom. We must have degree of freedom to get to something. We need to know the level actually. And here we have an example. It says, suppose a random samples of 49 silver tires and 36 dumb tires were selected. The sample mean mileage, the tire lasts for silver tires is 119,000 kilometers. It's for silver. Let's say it's 1. And this is 2. Okay? We have 2 types of tires. And each of these 2 types of tires have some properties. The properties I given. Now, N1 is 49. And N2 is 36. Then, for silvers, we name it silver by 1. Okay? This is the X bar. X bar for the first type. So X1 bar is 119,000. And for the second, look. And the standard deviation is 700. So it's still S1. Okay? It's S1. These two says the sample mean mileage. The tire lasts for silver tire is this one, and standard deviation is this one. So these two are both for the first time. Okay, both are for the first time. Now we say S1 is 7700. Now these are all for the first time, and the sample mean mileage for done tires is this one. So it's X2 bar. X2 bar is 118,000. And the standard deviation is 6,000. So S2 is 6,000. It says compute a 90% confidence interval on the difference of the 2 population means. So this difference of population means. That's the second topic. Difference of 2 population means. We have generally we have 3 cases. In the last 2 cases we have 2 subcases actually. In the first case we said if the variance is noun. It's not given that the variance is a noun. Means it's the first case. We don't go on to the second 2 cases. It's not written anywhere that the variance is a noun. It's not given, that statement. Means we use the first case. If it says here, if the variance is a noun, what we look? We look at the number of sample sizes. Sample sizes are both greater than 30. So it's the second case. Okay? It's the second case. In the second case, you have 2 subcases. Let me go here. If the variance is noun, what if it's a noun? If it's a noun, first we look at the sample sizes. Here we have 49 and 36. Okay? Both are greater than 30. So this case. In this case, we have 2 subcases. Which of them? Are the variances equal or not equal? The variances are not equal. One of them is 7,700 and the other one is 6,000. So the variances are different. We use this rule, the rule for the here. Okay? We use that case. But in this example, it's not given that the variances are a noun. Means it's the first case. It is the first case. We now have N1, N2, X1 bar, X2 bar, S1, S2. We just need these 6 things for obtaining the interval. And also we need alpha. We need alpha. Alpha could be obtained from this given information. It's always given. Okay? The percentage of confidence interval must be given because it's asking to find that amount. Okay, to find the interval for that percentage of confidence interval. So it should be given. Alpha here is 1 minus 0.9. It's 0.1. This is alpha. Let's return to the table. If alpha is 0.1, sorry. If alpha is 0.1, this one is. Z of alpha over 2 is 1.64. Now write down directly. Say Z of alpha over 2 is 1.645. That's it. We now have Z of alpha over 2. We have N1 and N2. We have X1 bar, X2 bar, and S1 bar, S2 bar. S1 and S2. Let's return to the rule. If you could get it from those given information or not. This case one. What else do you need except those given information? N1 and N2, sigma 1, sigma 2. Look, S1 and S2 is given. S1 is given. S2 is given. From this one, we could get sigma squared. This is standard deviation. Squaring standard deviation is variance. Okay, variance is S squared. You could get these two. Now we have these two, N1 and N2, X1 bar, X2 bar, and set of alpha over 2. Just calculation. Okay, you just need calculation to get the result. Where is it? That's it. This X1 bar, this X2 bar, and this is Z of alpha over 2. This is sigma 1 squared over N1, sigma 2 squared over N2. It's the left-hand side. How about the right-hand side? Just change this negative to positive. Okay? Calculate this and calculate this. For the left-hand side, find the subtract. Okay? For the right-hand side, find the sum. That's all. And we get the interval, which is minus 1,445.32 and 3,445.32. This is our interval. Means the difference of their mean is in that interval. It's in that interval. Okay? Any question? خب كشتان نية بس رولك بزانة هيك ثانية زور آسان recognize هنا زور آسانة چونکە پرسیارەکان بە واضحی ئەدرێ ئێسێمە وتمان 4 تۆپیکە خوێنین لێرە 5 تۆپیک 6 تۆپیکە خوێنین تۆپیک یەکەم بۆ مین بوو 1 مین ئەو یەکسەر پێ دەڵێ confidence for the mean تۆپیکی دووەم difference of two means لە پرسیارەکە ئەڵێ on the difference of the two populations یاخود ئەڵێ چی on the population means. So you need to find the difference. Okay? As you have two means, it's given means. As you have two means, we need to find their difference. Okay? Yes, let's take a break. Let's take a break for 10 minutes. We now have another topic, which is confidence interval for the population proportion. Up to now, we studied two topics. First, confidence interval for one population mean. Then, confidence interval for the difference of two population means. We studied these two. In those two, we have, in the first one, we have 3 rules. In the second, we have 5 rules. But now, In this topic, we have only one rule. Okay, we only have one rule. We say confidence interval for the population proportion could be obtained by this rule. We use this rule for obtaining the interval. We say pi is between these two. This is the left-hand side, and this is the right-hand side. And the difference between left and right-hand sides are only this sign. In the left, it's always negative in all rules. And in the right, it is positive. What are these P, pi, and those? P and pi are both the population proportion. Population proportion. So it depends on only population size, which is n, population proportion, and also z of alpha over 2. We just need to find these three for obtaining the interval. We need these three, pi or p are the same, z and also n. We just need these three and calculate to get the result. Look, pi here is replaced by p. It's the same. Pi and p, as I said, are the same. This is our rule. Look at this example. As I said, we have only one case here. Look at the end of the example. It says, for the true proportion, look, it says proportion. We need to find confidence interval for proportion. As we have only one population, we have one population or one sample size, means it is this case. It is the population proportion. It's the confidence interval for population proportion. Okay. Let's read the given example. It says a manufacturer of printed circuit board, PCB, is interested in estimating the fraction of defective units produced. A random sample of 200 boards contains one defectives. In 200s, there is only one defective one. Okay, we have only one defect. So from these two numbers, 200s and 1, we could get the proportion. What's the proportion? The proportion is 1, it's the number of defectives dividing by the total numbers. That's the proportion. We say it's 1 over 200s. So P here is 1 over 200s, which is 0.005. 1 over 200 is 0.05. That's it. It's P. What's N? N is 200s. It's the sample. N is 200s. We now have these two. What else should we find? Alpha. We need to have alpha to get Z alpha over 2. This is given. It's given that find a 90% confidence interval for the true proportion of defectives. From this one, we could get alpha. Alpha is 1 minus 0.9, as it's 90% means it's 0.9. 0.9. And this 0.1. We need to find Z of alpha over 2. What's it? Z of alpha over 2, we return to the table. In the table, we have given that if alpha to be 0.1, Z of alpha over 2 is 1.645. 1.645. That's it. We now have P, N, and Z. We replace these here. This is P, Z, this P also, and N. We replace here and here also. We find both sides. We could get both sides. بۆ ئاسانکاری خۆتان بۆی کە زوو یەکسەر ئەنجامتان دەستکەوێت چی بکەن وەرن ئەمە بدۆزنەوە ببن ئەمە لێکدانە ئەمە زەرب. This is multiplication. It's not less than. Okay? This is multiplication. Find this one and use it for both. Here's the same. In the left, subtract what you get from P. And in the right, add it to P. Okay? In the left, we have P minus this amount. And in the right, we have P plus this amount. Do jar amma dos no jari amma calculate kim zan chanaka jari tibza amma calculate kim zan chan. One chip dos nawa. Amma dos no. Amma dos nawa. Kama dos yok zan chane binus. Basha binus balat habit. انجا بولاي تشرشي يكين P ناقص أو راديه كده اسمعنا كده P ما دوزيو P 0.05 بولاي راست P زائد أو راديه so هذا ونده look at the example this is P minus this is Z of alpha over 2 then this is the square root. In the square root we have P times 1 minus P is this. Calculate this. It is 0.0082. Then, in the left you have P minus this amount. In the right you have P plus this amount. The same amount you have in both sides. But in the left you have P minus that amount, and in the right you have P plus that. And the result is minus 0.0032. And in the right, we have 0.0032. So our interval is minus 0.0032 and 0.0132. This is the interval. So the population proportion is in this interval. Okay? This is the interval of the population proportion for the confidence interval, for the 90% of confidence interval. That's it. If you know the rule, it's easy to calculate. It's only using calculate. That's this case. Look at this one. Here we have 200. It's N. And 17 defectives. This is from these two, you see P is 17 over 200. This is P. Okay? It says find 95 confidence interval for the true proportion. For the true proportion means from this one we could get alpha is 1 minus 0.95, which is 0.05. We need to find Z of 0.05 over 2. Find 0.05 over 2. It equals to, sorry, 0.025. So Z of 0.025 is what? Here, we look for this one in the table. This is alpha. Alpha is 0.05. Look, as you see in the table, we have no 0.025. It's alpha over 2. But we say if alpha to be 0.05, Z of alpha over 2 is 1.96. We now have N, P, and Z. Just like to here, you get the result. It's only calculations. So you have to know the rules. It's another one. This one, 6.5% of the sample. That's similar. Another topic is confidence interval for the difference between two population proportion. We now have the difference of the confidence interval for the difference of two population proportions. Here, it's only one case. It's not like the previous topics. It's only one case. Only the first and the second cases. In only the first and the second topics, we have some cases. But in the third and fourth, we have only one case. In the previous one, we just have one case, which was the confidence interval for the proportion of a population. Now we have the confidence interval for the difference between two population proportions. If you have two proportions, then we need to find the confidence interval for the difference of the proportions. We use this rule. In the previous one, if we have only one population proportion, we said it is P minus Z of alpha of 2 times square root of P times P minus 1 over N less than pi less than P plus Z of alpha over 2 square root of P times P minus 1 over N. This is the rule of the proportion for one population. If you have one population, how to convert this for two populations? For the difference of two populations. This is P, is if you have one population. What if you have two populations? It's P1 minus P2. Okay? And here we have Z alpha over 2. It's still the same. In the square root here, for one population, you have P times P minus 1 over N. In that case, we have 1N, 1P. Okay? But what if we have 2N and 2P? We say adding to the second one. For the first one, it's the same. Adding to the second one. Okay? We have two populations. If we have two populations, we have this plus the same for P2. That's the left-hand side. For the right-hand side, it's the same. It is the same. Change this to P1 minus P2. And changing this, it's for 1. How about 2? Let me just expand this for 2. For 2, we say it's P1 plus, it's N1. P2 minus 1 over N2. Okay? That's how to construct the confidence interval rule for two population, for the difference of two population proportions from one population proportion. If you know the first, for one population proportion, it's easy to construct for two. كواتا بيوزناك أما استعمال بيوزناك هل السرية كم هو أتوانين construct وايا أجر بيشتر بزانن آسان أمان شون دروسه. In the previous one, we said for one population proportion, we said it's P minus Z of alpha over 2 times square root of P times P minus 1 over N. أما لا يتشال لا راست هماشت ونيا بلام أو زائد أو ناقص أو بزائد طبعا. أما أجا يك population أو أجا يك proportion معه. What if we have the difference of two population proportions? Difference of the proportions. Okay, means P becomes here P1 minus P2. As we have two proportions, it becomes P1 minus P2. Z is still the same. Then the square root becomes, this is for one population proportion. How about two? We say it's P1, that's for the first one, P1 minus 1 over N1 plus the second one, P2 times P2 minus 1 over N2. It's the left-hand side. How about the right-hand side? It's the same, just change this negative to positive. Look, it is the above rule. It's this rule. We now have an example about this for the confidence interval for the difference of two population proportions. Directly go to the end of the question or example. It says construct. If you know it is confidence interval, check. What case is? You could get it from here. Construct 99% confidence interval on the difference in proportions. So we now have P1 minus P2. Okay? And here it becomes pi1 minus pi2. Be careful with this. Okay? Here we get pi1 minus pi2 instead of having only pi. In the previous one, we just have pi, but now we have difference of them. It's pi1 minus pi2. It says the difference of their proportions. Now we need to find the interval for pi1 minus pi2. What are these? We have a rule for this. We have a rule for this. Now read the question. In a factory, plastic parts are formed using two different injection molding machines. Two random samples, each of size 200. Look, we have two samples, both have the same size, which is 200. Means N1 and N2 are both 200s. Let's write down the given information. You see N1 is 200s. And also N2 is 200s. Are chosen and 5 defective parts are found in the sample from machine A, from the population 1. Okay, and 6 defective parts are found in the sample of machine B. Means P1 is, in the first group we have 5 defectives. In the second we have 6 defectives. Okay, P1 is 5 over 200. Okay, and in the second we have 6. We have 6 defectives. From these two, we could get P1 and P2. P2 is 6 over 200. Calculate this. Okay? Then it says construct 99% confidence interval on the difference in proportions of defective parts. So it is the rule of difference of two proportions. It's difference of two proportions. Now let's find alpha. Alpha is common in both proportions, in both populations. Okay, so Z of alpha over 2 is, let's first find alpha. Alpha is 1 minus 0.99, which is 0.01. Okay, it's 0.01. Then Z of alpha over 2 is Z of 0.01 divided by 2 is 0.005. Okay, we don't look for this value in the table. We look for the value of alpha in the table. It's 0.01. Let's look. 0.01 Z of alpha over 2 for 0.01 is 2.575. This is 2.575. Use this one for Z of alpha over 2 in the rule. We now have z of alpha over 2, n1, n2, p1, p2. Let's look at the rule. What else do we need to find? P1, P2, N1, N2, and Z of alpha over 2. We don't need anything else. Okay? Just look at one side of the rule. Look at this side, and the other side is the same. But this negative sign becomes positive. P1, P2, we found these. P1, P2, we found these. N1, N2, we have these. We have Z of alpha over 2. So we don't need anything else. We just plug these into the rule. We get the results. It is P1 minus P2 is P1 minus P2 is, it's not written, 0.03. 0.03. Okay? It's P1 minus P2. Only P1 is written here. It's a typo mistake actually. Minus Z of alpha over 2, we found this, times the square root of P1 times P1, 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. That's the left-hand side. Calculate this and find this subtraction. 0.025 minus 0.03. It's it's minus 0.005. This one is 0.025 minus, it's P1 minus P2. It's P1 minus P2. And this one is, calculating this is 0.0421. Now, in the left, you have this amount minus this amount. In the right, you have this amount plus this amount. That's all. Look, in the left, you have the difference of proportions minus the calculation of this one. And in the right, we have the difference of proportions plus that amount. Okay? And the result is minus 0.0471 in the left. And in the right, you have 0.0371. So our interval is minus 0.0471 and 0.0371. This is the confidence interval of 99% for the difference of the proportions. That's it. So the difference of proportions is in this interval for those two populations. Any question? Here, it just depends on the rules. If you don't know rules, you don't know anything. Okay? Because you directly start from using the rule. If you don't know the rule, what you do? Nothing. Try to memorize the rules. Don't leave it for near the exam days. Okay? Try to memorize nowadays before starting the exams. Now, the next topic is confidence interval on the normal population variance. It's 4 variance. And then we have for the ratio of 2 variances. Okay? We have 6 topics. First one for 1 mean, then for difference of 2 means. And then for 1 population proportion, for the difference of 2 population proportions. It's 4. And then for 1 variance, for the ratio of 2 variances. Okay? Each 2 related to each other. Okay? The confidence interval on the normal population variance, if you have 1 variance, that's here we say you have variance here, 1 variance. For the ratio of two variances, in the middle we have sigma 1 squared over sigma 2 squared. Okay, it's the ratio. For the difference, we have no difference for variances. For proportions, let's say, for proportions, for one proportion, we had only pi in the middle. For the difference of two proportions, we have pi 1 minus pi 2 in the middle. But for mean, for one mean, we had only one mu in the middle. But for the difference of two means, we had mu1 minus mu2 in the middle. Okay? We now have the confidence interval for variance. In this case, in this type of confidence interval, we need to use the table of chi-squared. This is read as chi-squared. We say it depends on n variance or standard deviation squared and alpha. It only depends on these three things. Alpha is always given in the example and must be given because without having a sample size, we don't know what we do. Okay, we must have sample size, which is n. And s squared is variance. Even if we have given the standard deviation is s. Squaring it, we get variance. Okay. You must have either a standard deviation or variance, and also n and alpha. If you have these, we could get the result. Look at here. This is the rule. Before we start to solve a question, let me tell you how to work in chi-square table. Chi-square table. Let's say if you have alpha over 2 here, let's say alpha to be 0.05. Okay, let alpha to be, let's say, 0.2. How about alpha over 2? Alpha over 2 is 0.05. What's the chi-squared of 0.05 and n minus 1? Let's say we have 20 samples. Okay, 20 minus 1 is 19. Let's find this one in the table. We look for table of chi-squared. It's F. This is still F. And it's F. This one F. Still F. And then this is T. This is chi-squared. We look for chi-squared of 0.05 and 19. Where's 0.05? This is 0.050. As we have this small here, it's 0.05. Okay? It's 0.050, means it's 0.05. This one is. This column is. We look for 19 in the other column. We look for 19 in the other column. This is 19. And here is this. It is 30.14. Okay? That's how to use chi-square table. Now, let's return to here to solve a question. We now have an example. It says a study on an operating, before we read it, let's see. how to recognize that it is this case. It says, assume that the response time follows normal distribution. Construct 95% confidence interval on the true variance. It's given variance, okay? And it doesn't say difference of variances or, sorry, the ratio of variances or something like that. So it's, as we have only one population, so you should directly know that it's this case. Now let's read the question. It says a study on an operating system for a portable computer has been carried out thoroughly to estimate the variance of response time. Up to now, we have nothing. Okay? It says a random sample of 10 portable computers are chosen. What's this n? It is, what's this 10 is n. Okay? This is n. Give the standard and give the standard deviation value of 8. So S is 8, N is 10. And then assume that the response time follows normal distribution. Construct 95% confidence interval on true variance of response time. Now, from this, we could get alpha. Alpha is 1 minus 0.95, which is 0.05. Okay? It is 0.05. Then, alpha over 2 is 0.025. You know, alpha over 2. We have alpha over 2, N and S. Let's return to the rule. You write down the rule and look at the rule if you need anything else. What else do we need? We have S, which we could get S squared from S. We have given N, and we found alpha over 2. Everything are given. Okay, everything is given. Now, we need to find chi-squared for alpha over 2 and n minus 1. We need to find chi-squared of alpha over 2, which is 0.025, and n minus 1. What's n? N is 10. 10 minus 1 is 9. We need to find this one. Let's find it. From the table, we say this 0.025 and 9. 0.025, this is 0.025, and 9. It's 1902. Is it? It's 1902. That's chi-squared. It's for the left-hand side. Be careful with that. In the right-hand side, we don't have the same. In the right-hand side, we have chi-squared of 1 minus alpha over 2 and n minus 1. Okay? This is for the left-hand side. This is the... Sorry? This one? How to find this one? Okay. We say we need to find chi-squared of alpha over 2 and n minus 1. N is the sample size, which is 10. Minus 1 is 9. Okay? And alpha over 2, alpha could be obtained from this. It's 0.95. It's 1 minus. We always say alpha is 1 minus this amount. 95% means 0.95. Look, we use this in the table. We need to have two components in chi-square. Okay, alpha over 2 and n minus 1. We need to have both. Alpha over 2 is 0.025. That's it. And this is n minus 1. We go on to the table. The table is given in the exams. Look, what's 0.025? This one is. It's 0.025. Means it's 0.025. Then find 9 in this side also. Okay, this is the second component. The column, the first column is the second component, which is n minus 1. And that one is alpha over 2, which is 0.025. Now, try to find this. Go here, and then come to down. What's the cross value? It is 19.02. Okay, it's how to find that. Then we need to find chi-squared of 1 minus alpha over 2 is 0.025 and 9 again. It's for the right hand side. In the right hand side, 1 minus alpha over 2 and n minus 1. Let me write down this. Alpha chi-squared of 1 minus alpha over 2 and n minus 1. We have this in the right hand side, but in the left hand side, you just have alpha over 2 and n minus 1. You need to find both because they have different values. What's the value of 1 minus 0.025? It's 0.975. Okay, this equals to chi-squared of 0.975 and 9. Look for this one in the table. Look for this one in the table. Let's return to the table. 0.975 and 9 is 2.7. Okay, the other one is 1902, but here it is 2.7. Okay, it is 2.7. We now have chi-squared of alpha over 2 and n minus 1. Chi-squared of 1 minus alpha over 2 and n minus 1. We have these two. And we already found both s and n. We just plug it to here. This is 19.02. This is 2.7. N minus 1 is 9. S squared is 64. This is 9, 64. We found S. S is 8 and N is 10. It's given in the example. Just replace them. You get this one. We found this one's 19.02 and this is 2.7.
The S has to be the even number of words.
Sorry?
The S to be equal number.
S? No, S is sample size. جماري دانا كان شن دانا معناه ده معناه بيس معناه سمع هاتشن it could be even or odd, but it must not be 0 or negative. Okay, because when you say we have something, so the number of those that thing must be greater than 0.
But if it was like negative, the equation is too.
If it's negative, no, it must not be negative. Okay. كاتب باسكين علي أو نشتمان أو ندانا من فلانش هي شن دانا هناك يبغى ناقص كيف دانا ونيا كواتا نابي negative. So the interval is just calculation. It is this. So the interval we say it's 30.279 and 213.333. This is the interval. Okay. Any question? again يعني تين يا جماعة أو إلى سر إيه مناتو أم فولا كتان في لبركة أيو خطان بريد باشا تسوي تلك معوتو أحسان إيش تانية. We now have the last topic, which is the confidence interval for the ratio of two normal population variances. In the previous ones, we said difference of two means, difference of two proportions, but here for variance, we say ratio of two variance. Okay? We say ratio of two variance means variance 1 divided by variance 2. Here, we use this rule. This one. Look, in the previous one, we have this rule, but here we have 1 minus alpha over 2. Actually, the better way get. Look, available again. اسم مجالي الثاني هنا بس. زاد شن انا انس. والله بيبقى جريدة والناس اشتخوف انا هوام الله يبقى بيدوسين. اي بيبقى جريدة. انا اشتخوف نوسين روتي. لا هنا هول بالنبر يعني كان استفكر ايش نعطيها مثلا نوسيني رولا كان. نسال او رولانك عديت اللي هو توان كونستراكت يعني. باشا كتانا بالنسبة. We have this, but you don't need to memorize this one. Don't use this one, because in the F table, if let's say alpha to be 0.1, if alpha to be 0.1, so f of alpha over 2 is 0.05, and let's say n1 to be 10 and 2 to be 15. Okay, and 2 minus 1, which is 14, and 1 minus 1 is 9. We could find this one from the F table, but for the f of 1 minus alpha over 2, 1 minus alpha over 2 is f of alpha, sorry, 1 minus alpha over 2 is 0.05. It is 0.95. F of 0.95, and n2 here, this is n1 minus 1, n2 minus 1. It's n1, and the second is n2. One minus 0.05. Vale. Here we have f of 1 minus alpha over 2. We already found alpha over 2. This alpha. So alpha over 2 is 0.05. 1 minus this one is 0.95. Okay? And n1 and then n2. Sorry. This one is n2. n1 minus 1 is 9. And 2 minus 1 is 14. We cannot find this one from the table, from the F table. We cannot find this from F table. What we do, we say, this amount is 1 over this one. Okay, so you just need to find 1F from the table for alpha over 2, n2 minus 1 and n1 minus 1. After finding this, just say 1 over that amount, you get the result. Sorry for this one. No, don't know that one. Instead of having, it's written here, n2 minus 1, n1 minus 1 is 1 over f of alpha over 2. Instead of 1 minus alpha over 2, we have only alpha over 2. We change to alpha over 2. These two components are the same. Okay, these two components are the same. So now, instead of that, you just need to memorize this rule. Okay, just this one. We say s1 squared over s2 squared times 1 over alpha over 2 n1 minus 1 and n2 minus 1. This is the rule. As we talk about ratio of variances, sigma 1 squared over sigma 2 squared, then s1 squared over s2 squared times f of alpha over 2. This is n2 and then n1. But in the previous one is n1 and then n2. Let's take an example to find it from the F table. Let's say if we have f of 0.05 and 14 and 9. Let's look for this one in F table. F table, we have I think 4 to 5 tables for F. This one is F of 0.25 V1 V2. V1 in our example is 14 and here is 9, is it? We cannot use this one. We cannot use this table because it's for 0.25. It's for 0.25. Let's look for 0.05. As you have 0.05, we need to look for a table for f of 0.05. It's 0.10. We don't use this. It's still f. Look, it's f distributed. It's 0.05. In this table, we look for 14 and 9 to find f of 0.05, 14 and 9. We found the table. And in the table, we look for 14 and 9. This one is the first component. And this one is the second component. Okay? Let's say change this to 15 because we have 15 and let's say 9. 15 and 9. Look at this. In this direction, we look for the first component. The first component here is 15. We look for 15 here. This one is. Okay. This is the first component. It's that column. And here, vertically, we look for the second component, which is 9. We look for 9. 9 here is this. Go through these to get that value, which at 15 and 9. That's 3.01. Okay, that's how to use F table. بو F چند تیبلێک مان هەیە. سەرتا سەیری بەردەم Fەکە بکە بزان چەندی ئەو ژمارەیەکە هەمان ئەلفا ئەو بە تووەکە. لێرە 0.05 کەواتە لەم تیبڵەیە بۆ ئێگەڕێ ناسم لەم تیبڵێکیانە بۆ لەم تیبڵەیە بۆی ناگەڕێ. Okay, because it's for 0.025. Alpha over 2 in this case is 0.025. Okay, If it's 0.025, I look for the result for the value in this table, and it's still F distribution. If it's 0.01, we use this table. So now we have 1, 2, 3, 4, 5 tables for F. We have 5 different tables for F. What are those tables? The tables are for these values. Okay? The tables are for these alphas.
Based on the value, we choose the table, or based on the example?
Based on the example. Look, in this example, based on the confidence interval, actually, here we have 95% confidence interval. We need to find it. We look for f of alpha over 2. Let's say n1, n2. Okay? And we also need to look for f of alpha over 2, n2, n1, each minus 1. In the row, we have these two. Okay? What's alpha over 2? Alpha here is 1 minus 0.95, which is 0.05. This is alpha. Alpha over 2 is 0.025. Look for table of 0.025. And then work on n1 minus 1 and n2 minus 1. Okay? And then work on these two components. Okay. Look at this example. In this example, as an example, فرم example ما رسوا لكن جاوبنا في تعلم شون constructi رولا كان لو رولا كأجهزة باشا شنو يعني بتواني constructi يعني هم يعني نتواني باشا بويكا نسي يستوى لبني بويكا هولبن اگر بتوان constructi كي لو رولا كأجهزة باشتري ونيا اگر بتوان سيان شواري شان constructi زور كات شواري لبنا كاتكي باني We have an example. It says a quality engineer is studying the diameter of stainless rod manufactured on 2 different machines. 2 random samples of 16 and 13. So these are N1 and N2. Okay? These are N1 and N2. N1 is 16. As we have the ratio of variances means we have 2 variants. Means we must have 2 populations. So we write down all given information for each population, for population 1 and 2. Here it says we have these 2 sample sizes for the populations. Let's name population N1 and N2 for their sample sizes, and 2 is 13. You have 2 sample sizes, 16 and 13. Reflectively are selected, which give the variances of diameter values. We have given the variances. This is S1 squared and S2 squared respectively. Second, شانزمان دانا بو N1 كواتك عليه variances يكم دانيان S1 زيما 1 squared وانيا دوم دانيان زيما 2 squared بوشيوي ولي variances. Here we say S1 squared equals 0.30, and the second is S2 squared is 0.40. You can see, you just could say 0.3 and 0.4. Assume that The data were drawn from normal distributions. Construct 95% confidence interval on the ratio of variances. A ratio of variances. So it's the last topic or the last case. Okay? Means sigma 1 squared over sigma 2 squared. We must find an interval for sigma 1 squared over sigma 2 squared. What are these? Okay. In this case, we need F distribution. We need F distribution. And the rule is sigma 1 squared over sigma S1 squared over S2 squared. Then we have 1 over F of alpha over 2. N1 minus 1 and N2 minus 1. And in the other side, we have S1 squared over S2 squared. We have this one here. But these are different. It is N2 minus 1 and then N1 minus 1. Okay? These was sweet. Okay? In the right hand side, N2 minus 1 is first and N1 minus 1 is second. But in the left hand side, F is in the denominator and N1 minus 1 and then N2 minus 1. We have this. Okay? This is the rule. This is one. Now, let's see what's given. N1, N2, S1 squared, S2 squared. And also, alpha is given. Alpha is 1 minus 0.95, which is 0.05. And then alpha over 2 is 0.025. Alpha is given also. Alpha is given, alpha over 2. We found this. S1, S2 are given. N1, N2 are given. In the other side, the same. Everything are given. We just need to calculate it. S1 squared over S2 squared. It is 0.30 over 0.40 times 1 over. It's written down. This is 0.30 over 0.40, 1 over F of, I am writing down here. It's 0.3 over 0.4 times 1 over F of alpha over 2 is 0.025. Then N1 minus 1, comma, N2 minus 1. It's the left hand side. It's less than sigma 1 squared over sigma 2 squared. And then less than the other side. In the other side, we have S1 squared over S2 squared, which is 0.3 over 0.4 times F of, it's in the numerator. F in the right hand side is in the numerator, 0.025. Then N2 minus 1, N1 minus 1. Let's find N2 minus 1, N1 minus 1. N1 minus 1 is 15. N2 minus 1 is 12. N1 minus 1 here is 15 and 12. But this one is 12 and 15. Okay? Because N2 minus 1 and N1 minus 1. We have these. It's 12 and 15. Now, we need to find F of 0.25 for 15 and 12 and 12 and 15. Let's look for 0.025. This is 0.01. This is 0.025. Okay. If V1 f of 0.025, 15 and 12. Hello? It's okay. Sorry? No, I haven't done it. Because
Thank you very much.
Now, we find these two components in the table, 15 and 12. 15 is the first component, which is the horizontal. 15 is this one. And 12 is this. Okay? Now, we look this for. It is 3.18, is it? It is 3.18. That's it. Now, f of 15 and 12 is 3.18. How about f of 0.025 and 12 and 15? 12 and 15. So we now have 12 here. Where is 15? It's here. It's 2.96. Okay? It is 2.96. Now we replace f of 0.25, 12 and 15 by 2.96. 12 and 15, this is 2.96. And this one is 3.18. Just replace them here. We get 0.3 over 0.4, it's 3 over 4. Okay, times 1 over 3.18. Less than sigma 1 squared over sigma 2 squared. Let me write down below. It's 0.3 over 0.4. These two decimal points, decimal places cancel each other. We get 3 over 4 times 1 over 3.18 is less than sigma 1 squared over sigma 2 squared is less than 3.04 times 2.96. Okay, times 2.96. Calculate these two. The left hand side equals to what? And the right hand side equals to what? The interval that you get is 0.2358 and the right hand side is 2.22. And the confidence interval is 0.2358 and 2.22. This is the confidence interval. Okay. Any questions? So it's end of this chapter actually, and this topic. And let's take a break for 10 minutes, and I'll give you some instructions about this. لم يسانوك أجيو أم يسان كان في الامتحان أتواني هم يسا كان تقريبا كونستراكتيف دروس كيتوا شون ليرة إما كاتيكا طبعا لهم example كان قد قد دابي أيود normal distribution ونيا distributed as normal ونيا أجر أو بو علين شيء بو رولي كم كهم عم بو شيء بو بأجيك population من منهجت وأجر population variance and out noun variance okay أمر لك بو اكتفى أمر الزجمة اللي رم بس ما إيسا standard deviation okay أمر لك يدي باب زام شون لم رولو كدراوة لم رولوا بيدوز ما شون زان أما يمينا هبا سريك ارتكاك سر زانا x bar minus ميو x bar 1 مينا باشا بلا أقل سيري أما يمكن difference of two means وايا أقل سيري دواتر كين أما تشيا pi و p همان با proportion یک دانه أي أمان two proportions وانيا همو أمانات وين دروس كينهم باب ثاني ليه كموا هل كانت زد تنبيني بكم بزد of alpha over 2 باشا كانت الليلة أم زد تشيا z of alpha over 2 يكسانة بشي x bar minus mu دا بشي سيجما over الرقي n شون ميو بدوس مو شون ميو بدوس مو ليلة باشا دين چیە کەین دوولا دنیاوان یەکەین ئەمەی لێرە هەمانە ئەچێتە سەرەی کردەکە ئەیە بەچی زیگما سۆی z of alpha over 2 زەربی زیگما over ڕەگی n لە لای ڕاست چی ماوەتەوە x bar minus mu ئەم میوەی کە هەمان هەمیشە موجب بێت وایە هەمیشە ئەبێ موجب بێت کەواتە میو لە نێوان چی و چیایە ئەم ئەکس بارە ئەبینە ئەو بەر بەڵام لە لای چەپەوە ئینتێرفاڵەکەمان ئێمە میومان هەیە لای چەپ و لای ڕاست لای چەپ ئەکس بار ناقص ڕادەیەک لای ڕاست ئەکس بار زائید ڕادەیەک ڕادەکەمان چیەکە هەمانە ئەمەیە باشە ئەمە بۆ وەن مین ئەکاتە چی ئەکس بار ناقص z of alpha over 2 times sigma over ragi. In the right hand side, we have the same, but changing this negative to positive. We have x bar plus z of alpha over 2 times sigma over square root. Let's compare this with the rule. You got the same. Okay? So it's easy to construct. Is it? بۆ ڕوولی دواتر بابزانین چی کەمان پێ ئەدرێت لێرە ئاتەنەوەی کاترێت بە نسبەت تی دیستریبیوشنەوە پێمان نادرێت باشە بە نسبەت نۆرماڵەوە پێمان ئەدرێت نۆرمال دیستریبیوشنەوە پێ ئەدرێت ئەگەر هاتوو difference of two meanمان difference of two means چەند کەیسێکمان هەیە وایە بەڵام ئەگەدار ئەمە هەموویانی پێ ناکرێت هەموو حاڵەتەکانی ناتوانین پێ دروستکەینەوە هەموو حاڵەتەکان ناتوانین دروستکەینەوە باشە بەڵام زۆربەی حاڵەتەکانی پێ دروست دەکەینەوە ئەمەش تەقریبەن ڕوولەیەکی پێ دەرەکرێت ئەمە ڕوولەیەکی پێ دەرەکرێت وانە بەڵام ئاگاتان لە سەبسکریپتەکان بێ بۆ زێت هەمیشە ئەلفا ئۆڤەر 2 هەی بۆ تی چییە تیە بێ دوو کۆمپۆنێنتمان هەبێ ئەلفا ئۆڤەر 2 v چییە v لێرە دەستمان دەکەوێت v degree of freedom باشە بۆ ئەمی تریان لەمە بزانین چ ڕوولێکمان دەست دەکەوێت با بزانین چیمان دەست جا دوولا دنیاوانەیە زێت چییە زێت ئۆف ئەلفا ئۆڤەر 2 ئەکەمە زێت ئۆف ئەلفا ئۆڤەر 2 کەواتە چیمان هەیە زێت ئۆف ئەلفا ئۆڤەر 2 ئەم ڕەگە ئەبەینە ئەو بەر هەیە بە لێکدان ڕەگی زیگما 1 سکوێرد لەسەر n1 پڵەس زیگما 2 سکوێرد چی ماوەتەوە لە لای ڕاست چی ماوەتەوە ئەمەی کە هەمانە difference of two meanە وایە it's difference of two means ئەمە گرنگە بیزان ئەوەی کە ئاسانە بۆ دانانە ئەڵێن چی بۆ difference of two means we say mu1 minus mu2 it's between in the left hand side we say x1 bar minus x2 bar minus something and then in the right we have x1 bar minus x2 bar minus something. What's this thing? It's this one. Just put it there. You'll get the rule. Let's return to the rule here and you will see that that's it. It's x1 bar minus x2 bar minus this amount. We found that. And in the right, x1 bar minus x2 bar plus this amount. As you see, we obtain this. Okay. Once we multiply this by that one, we say it is z of alpha over 2. And here it is another case of difference of two means. In difference of two means, we said we have three cases. And the first case is only one case. And the second two cases, we have two subcases in each. Okay? Here we have ASP. ASP is given. And then this is Z of alpha over 2. We get Z of alpha over 2 times ASP square root of 1 over n1 plus 1 over n2. Which case is this? It's in one of the cases that the variance is unknown. If the variance is يك لو كيساني كفاريانس نسان دو حالة ما نهب يعني n1 يعني n كان قولترين للسي يعني n كان بشوكترين للسي يعني قولتر بناء للسي أو كاتعتين فاريانس كمان بلاوده يكسان يعني يكسان أجاب بشوكتر بهمان شوي بلاود معنا كده يكسان يعني يكسان أما يك لو حالة كان بس recognize الرولا كاب كان بزان كان رولي وبكاري يعني بون من أمر رولا بوشي بكاري لكان أنا بكاري يعني لكان كيسان باشا هەڵبەت ئەمانە بزان ئیتر دروستکردنەوەی ڕوڵەکە لێرە و ئەتوانی ئەمە پێم دروستکردەوە ئەمەمان هەیە سەرەی کەرتەکەی کە ماوە چییە difference of two means difference of two means لە لای چەپ و لە لای ڕاست x1 بار minus x2 بار بۆ دوازیە کرد لای چەپ ناقص ئەم ڕادەیەکە لای ڕاست زایدەوە هەرەوەنێ بۆ ئەمەیان ئەمەش کەسێکەیە بەڵام ئەمە تی distributionمانە لە تیا پێویستە ڤیش بدۆزینەوە وایە لە تیا پێویستمان بە ڤیش هەبوو ئەمە ڤیە پێویستمان بە ڤی هەبوو کاتە ڤیش ئەدۆزینەوە هەر کاتە تیمانە چونکە ئاڵێن چی t of alpha over 2 v لەوانەیە alpha over 2 کە لە ڕوڵەکە نەنووسرابێ بەڵام پێویستمان بە v هەیە v degree of freedom ئەگە سیرکەین لە ئێرە ئەمە تیە لەوانەیە alpha over 2 گریمان ئەکات 0.1 ئەی ڤیەکەی چەندەیە ڤیەکەی ئینتیجەرە بێ دەرچێت ژمارەیە لەمانە دەرەچێت لەگەڵەوە بەراوردی دەرچێت باشە ئەمە بۆ تیەکان هەموو شێوەیەن ئێستا ئەمانە ئەمە زەربی ئەوەیەکەین با بزانین چیمان دەسەکرێت لێرە ئینوسم لە خوارەوە ئێ بەچی t of alpha over 2 هەر بیکەین بە سمۆڵ ئەو تیە مادام هەر لێش بە تی سمۆڵ t of alpha over 2 زەربی ڕەگی دووجای s1 دووجا over n1 plus s2 دووجا over n2 ئەمەی کە هەمان لەسەری کەتێک چیمان هەیە difference of means کاتەم بچووکترە چی mi1 minus mi2 بچووکتریشە لە چی هەمان ڕادەمان هەیە باشە با بینوسینەوە t of alpha over 2 ڕەگی دووجای s1 دووجا over n1 plus s2 دووجا over n2 باشە لێرە چیمان هەیە لەبەرەوەی difference of meanە difference دوو مینە کەواتەوە differenceەکان لێرە بنووسم لەولاش بینوسم ئەڵێم x1 بار minus x2 بار minus هەم بەڵام لە لاکەی تەڵێن زاید لێرەش بە هەمان شێوە x1 بار ناقص x2 بارمان هەیە بەڵام زائید ئەو ڕادێ زای ڕوولی وامان هەیە ئەمان نییە ئەمە SP لەگەڵ ئەمە ڕوولی پێشتر بوو ئەمە کەیسی دووەمە ئەمە ئای بوو ئەمە دەبڵ ئای بوو ئەم بۆ حاڵەتی سی بۆ حاڵەتێکی تر سوري اما بو تي ديستريبيوشن اما سروا يعني هل ما اشت تقريبا بس ام دوجانا معني وتاولين اما يكن امر والله بكار بيني يك هل ما اشت بلام ليرة تشيش مان هيا اس بيش مان هيا ضربي تكراوا وايا اما اس بي اس بي اس بي اي اس بي چيا اس بي دراو لرولا كان بو انون انتو اسون ويستو يدوسي كواتە لێرە هەموو شتێ دراوە وەنیە بەس کۆنسترۆکتی ڕووڵەکەکەم چیم پێویست بێت SP هەر شتێکە هەیە هاتوانین بدۆزینەوە کەواتە لێرە ئەم ڕووڵەی کە هەمانە کۆنسترۆکتمان کرد بەهۆی ئەمەوە توانیمان بیدۆزینەوە یاخود بۆ یەک پرۆپۆرشن ئەمە ڕووڵەکەی ئەمڕۆ وتمان ڕووڵەکەی کاتە چی ڕووڵەکەی کردە پی ناقص z of alpha over 2 ڕەگی دووجای پی ضربی پی ناقص 1 over n ئەمە بچووکتر بوو لە پای ئەمە بچووکتر بوو لە پی زائد z of alpha over 2 ڕەگی دووجای پی ناقص پی ضربی پی minus 1 over n ئەمە ڕووڵەکەی بۆ 1 proportion باشە چۆن ئەمە دروستکەمەوە چۆنەوە دروستکەینەوە پی و پای یەکشتن کاتە جانە جێ پی پای دابنن جێ پای پی دابنن باشە کاتە لەمەوە ئەگە دوولا دنیوانەکەی بەچی z of alpha over 2 وەکو زێتمان هەیە لە جێ ئەو پایانە پی دان چونکە لێ ڕووڵەکە پی بەکارهێن پی ضربی پی minus 1 لەسەر چی n ئەمە بچووکترە لە چی پای بچووکترە لە چی ڕادەیەک زائد ڕادەیەک زائد باشە بابی نووسمەوە پی z of alpha لەسەر 2 ضربی پی ضربی پی minus 1 over n بەڵام لێرەش ئەمە چییە پرۆپۆرشنە کاتە لای چەپەوە ئەلەم پرۆپۆرشن ناقص ئەو ڕادەیە لە ڕاست پرۆپۆرشن زائد ئەو ڕادەیە کەواتە چیمان هەیە لێرە پیمان هەیە پی ناقص پی زائد بابچینەوە بۆ پرۆپۆرشن لە دیفرەنسی پرۆپۆرشنمان ئەمە ڕووڵەکەی هەر هەماشمان دەسکە کەواتە توانی ئەو ڕووڵانە دروستکەیتەوە بپێ چەند ڕووڵ بۆ دروستکرا بزانم ئەم ڕووڵانە پێ ئەدرێتەوە بزان چەندیان توانین دروستکەیتەوە چەندیان ناتوانین هەوڵ بە بۆ بزان باشە اینجا یەک شتێکە کە لێرە باسم نەکرد ئەوی ڕاستی ئەگەر هاتوو بۆ نمونە این نەدرا ڤارێنس نەدرا بەڵام داتاو درابوویە ئەوتان خوێندووە چۆن ڤارێنسە دۆزیەوە لە چاپتەرەکانی سەرەتا ئەگەر داتاو پێ بدرێ ئەبێ خوێن بێتە for example if you have these data it's for two proportions okay we need to have mean variance we must find these two from these two tables okay for this one write down these beneath here okay that means we have 1 2 3 4 5 6 7 8 9 10 we have 10 data for let's say n1 is 10 and n2 is 10 n1 is the number of data so the sample size is 10 here and n2 is 10 both are 10 if this for population difference of population means it's in the case that n1 and n2 are less than 13 okay ئەمە لەو کەیسەیە کە n1 و n2 سامپڵ سایزیان بچووکترین لە سی چکار دوگەندەن کەواتە دین لێرە چیەکەین بۆ دۆزینەوەی مین چیەکەین x بار x1 بارەکاتە چی ئەکاتە کۆی هەموو ئەم ئلیمنتانە 4 5 6 7 8 9 10 ئەم دەدانەی کۆکەینەوە دابەشی چیەکەین دا ئەمە x1 plus x2 plus تا xn دابشی ده اما اکسپارمان توسیو ای چون variance توسم دیم اما به یک کلم باید بنویسیم اما 0.7 0.3 0.1 0.5 10 10.5 10.2 9.9 10.3 and 10.2. We have these 10 data. Now, to find the variance, we need to first find the difference of these data and the mean. We subtracting from these all, okay? Minus x bar, minus x bar, minus x bar, minus x bar. We have only one x bar for these data. We subtract that x bar from all data and then square them. Square these all. And find the sum of these. واتە x بار لە هەرێکیان دەرەکەین سکوێرێکی دەرەکەین سکوێرێکی دواتر هەمویان کۆکەینەوە ئەم سکوێران باشە کە کۆمان کردەوە دابەشی چیەکەین n ناقص 1 ئەوەی کە دەستمانەکەوێت چییە variance ئەوەی کە دەستمانەکەوێت variance بەڵێ
This is the last case that we had two variances.
سێکە ئەمە نازانم چ کەیسێکە بەڵام ئەگەر شتێکی وا هەبوو بە داتایای ڤاریەنس شتینیا بوو بەس ئەوەتان پێڵم چۆن بتوان ڤاریەنس بدۆست چونکە لە زۆربەی هەنە ڤاریەنسمان پێویست وانە ئەگەر داتاییە ڤاریەنسی نیاوە ئێکس باری نیاوە مینی نیاوە چۆن بیدۆزمەوە وانە ئەبەم شێوەی دۆزین ئێکس بارمان بەڵێ نادات هەمان ئەنجام دەرناچێت هەمان ئەنجام دەرناچێت جارێ بەرەوە هەرێکێکە ناقص ئێکس بار بکەن دوو جایکەن جا دووەمدا ناقص ئێکس بار دوو جا ئەنجامی دوو جاکان هەم کۆکەرەوە دواتر ئەڵێن ئێس سکوێر دەکاتە چی ئەکاتە سەم دابەشی ئێ ناقص یەک سەمەکە چییە ئەلێ دەستکەوت ئەمە چیمان دەستکەوت ئێس سکوێر واتە standard deviation نه variance نواب زام ئەمە هینە variance ئەمە variance باشە variance من دۆزیەوە x بارشمان دۆزیەوە ئەوەی کە پێویستمان هەرو دوانێن لەگەڵ n چیە لێرە n1 دەیە n2 چەندێ هەردێ بۆ ئەمیش بە هەمان شێوەی دۆزینەوە بۆش بە هەمان شێوە باز یەک چێکێ بکەنم بزان ئەمە standard deviation یاخود variance ئەخم بەسم ئەمە variance یان ئەمە سکوێر ڕوتی لەگەڵ وازان بۆ standard deviation با یەک چێک بکەم یەک چێکێ بکەمەوە بۆتان ئەمە وابزانم هینە standard deviation calculating step by step وازانم نایە ئەمەی کە هەیە ڤاریەنسە بەس بازام دابەشی ئێنێکان ئێن ناقسێک چونکە ئەمە بیرم نەماوە ڕاستی بۆ ناکەیت ئەمە میومان دۆزیەوە میواتە ئێکس بار نزیکمان سکوێر تاوە ئێن چەندانەیە هەشت تاوە دابەشی ئێن یەکەین بۆ سیگما This is dividing by n, not n minus 1. بەڵێ دابەشی n یەکەین ئەمە بریتە لە چی؟ بریتە لە ڤاریەنسمان دۆزیەوە مینیشمان دۆزیەوە بەهۆی دەیتاکەەوە کاتاکە دەیتامان پێدرا ئەگەدار بن ئەگەر دوو دەیتا درا بۆ دوو پۆپولیشن جیاواز ژمارە دەیتاکان ئەوێ بە چی؟ ئەوێ بە پۆپولیشن سایزەکەمان N1 و N2 لەم دوانەوە لە هەرێکێکانەوە توانین ئەکسپار بدۆزینەوە ئەتوانین سکوێرش دۆزینەوە تا ڤاریەنس و مین دۆزینەوە ئەگەر ئەمانە بزانین N و ڤاریەنس و مین بزانین هەمویان دیپێن دەکەنە سەرەوە وەنیە هەموو پرسیارەکان کەواتە پێویستە ئێمە ئەوانە بدۆزین لە دەیتاکان ئەگەر سەر لێرە پرسیارێکی یاوە دەیتایە هینیاوە لێرە ئەگەر سێکێ بگەڕە هیچ شتیان نییە هێنیتیان نییە بۆن منە مینیتیان نییە هیچ شتیان نییە داوای چیشی کردووە find 90% confidence interval mean for the difference of means داوای ئەوەی کردووە کاتی پێستان مینەکانی ژەوێت ڤاریەنسەکانیش هەردوو ڤاریەنسەکە هەردوو مینەکە دۆزین باشە ئەمە لێرە هینەکەی یاوە ڤاریەنسەکە ڤاریەنسەکە 0.3 هەموو تێتی هەردووکە هەمان شتیان هەیە بەڵام ئێمە پێویستە مینەکان بدۆزینەوە خۆمان بۆی کە بەکاری ئاتەن لە ئیمتیحانە یان داتای کەم دەهاتێ یان کە داتای زۆریە ڤاریەنسەکان دەهاتێت چونکە ڤاریەنسەکە کاتی دای دۆستەوە بەڵام مینەکە ئاسانە کۆی هەمویان دابەشی ژمارەدانەکان دەستەکە یەکسەر جا تەواوی ترسێنەرەمان هیوادارم سەرکەوتوو بن ئینشەڵڵا و هەر